one more example. Designers slab base for a column section ISHB 350 at 710.2 Newton per meter, subjected to an factored axial compressive load of 1500 kilonewton. Load is transferred to the base plate by direct bearing of column base. The base rests on the concrete pedestal of M20. And the solution is, first of all, we'll assume grade of steel Fe410, and for Fe410, Fu is equal to ultimate capacity of the steel, which is equal to 410 megapascals. Yield strength is 250 megapascal, and for M20 grade concrete, bearing strength of concrete as per code is equal to 0.45 ck, which is equal to 9 Newton per mm square. As per IS 800 2007, partial factor sector is 1.1, and for weld it is 1.25 for shop welding. Now from our handbook or steel table, we have properties of ISHB 350. Thickness of flange TF is equal to mm. Thickness of web TW is equal to 10.1 mm. Depth of section D is equal to 350 mm. Width of flange 250 mm. So area, we'll calculate first of all area of the slab base. A is equal to load in Newton divided by bearing pressure in Newton per mm square, that is equal to 0.16 mm square. Let us provide the rectangular base plate of length of size L by B and assume the overall overhang of the base plate, let A is equal to B. Now we have to find out this overhang B. So area of the base plate, we will get L from our handbook, 350 plus 2A. A is unknown, we are going to find out this, multiplied by B is equal to width of flange, that is 250, and we are assuming A is equal to B. So A becomes 555.24 mm. Take A is equal to round up 60 mm. So therefore L we get as 470 mm and width is 370 mm. Now the bearing pressure of the concrete is determined by W is equal to P by A1, which is equal to 1500 into 1000 divided by 470 into, and that is actual area, 470 into 370. Now the value comes out to be 8.62 Newton per mm square, which is less than 9 Newton per mm square, which is alright, which is okay. What is 9? We have given the grade of concrete as 20 Newton per mm square. From 20 Newton per mm square, the bearing strength of concrete, that is 9 Newton per mm square, which is equal to 0.45 FCK. 0.45 into 20, that is equal to 9 Newton per mm square, which is greater than 8.62. So it is safe. Now to find out the thickness TS, which is equal to 2.5 W into A square minus 0.3 B square into gamma m naught by Fy. This equation. Bearing pressure, this is smaller projection, P is also the smaller projection. So here we are taking A is equal to B. So 60 into 60 gamma m naught by, so here you can see, so 2.5 8.62 into 60 square minus 0.360 square divided by 1.1 divided by 250 equals 15.458 mm. We can provide thickness TS equals to 16 mm. First of all, we have seen that it should be greater than thickness of flange. So what is the thickness of flange? Let's go back and see it. It is thickness of flange 11.6.